Today we're going to discuss significant digits, or what is also known as significant figures. These are numbers, usually before or after a decimal place, that give us an indication of how accurate a measurement might be. These are rules or sig figs that we're going to apply to measurements only. Exact numbers like constants, we don't mess with those. They're already considered significant enough. So when we take a measurement, we get a number of decimal places. We have to determine how many of those decimal places are going to be important to us. So for instance, there might be a difference between 5.0 grams or 5.0000 grams. When I have these extra zeros, it shows that I took the measurement to this level of accuracy, that I took the time, or I used a specialized enough instrument to see how accurate I could get, how many decimal places I could get, essentially. However, not all instruments are that accurate. I mean, it's the equivalent of using a nice graduated cylinder with distinct milliliter graduations versus a measuring cup from baking. So there are certain instruments that don't have this level of accuracy. So we want to only represent the level of accuracy we can get to. So 1 decimal place, say. So, to count the number of significant figures in a number or a measurement, it's basically about non-zero digits. It's about the numbers, and then there's also what we call placeholder zeros, and we're not going to count those. So let's take a look at some examples to put this in perspective. Here are some numbers, some measurement numbers that we're going to look at, and we're going to describe how many significant figures there are and how we got to that number. So for instance, in this first one, 1, 2, 3, 4, 5, or 12,345, say it was grams, milliliters, whatever you have. This would have 1, 2, 3, 4, 5 significant digits. There are 5 non-zero numbers. There's technically a secret little decimal place there that we don't include. This has 5 significant figures. This is the level of accuracy to which this, whatever it might be, was measured. In this situation, the next one here, we only have what we call 1 significant digit. This zero out front is what we call a placeholder zero. This placeholder zero does not affect our measurement. It's just telling us that we are in the tenths position with this 5 as opposed to being in the ones position. The placeholder zeros are not counted as significant, and thus this one only has 1 significant figure. For the next one, we see that there are 3 significant figures. We have our placeholder 0 that we don't count, and then we count the non-zero numbers after the decimal place. So 3 significant figures. Where it gets a little bit different is when these situations where we have these after the zeros after the number. So remember, there's a secret little decimal there. However, in this situation, we only have what we call 1 significant digit, or 1 significant figure. This 5 is our significant figure. The zeros after are considered placeholders. They are telling us that we're in the thousands position as opposed to the ones or the tens. So they're placeholder zeros. They do not add any level of accuracy. In fact, they could have been rounded. This number could have been 4,998. But it could have been rounded to 5,000, which means that we don't have that level of accuracy. So this only has 1 significant digit. This next one, however, seems to be a very similar number. However, it has more significant digits. It has 6. These zeros here are not considered placeholders because they are followed with zeros after the decimal place. So this one has 6 significant figures. The next one here, these microliters, 505.01 microliters. This one will have 5 significant digits. These included zeros do get counted. They are not considered placeholders. And in our last one, our 100 kilograms, we have 1 significant digit. These zeros are placeholder zeros because they're not surrounded by a decimal in any way, and so we would consider that 1 significant digit. So it's fairly straightforward to identify the number of significant figures in a number. However, when we're using these numbers or these measurements in problems as data, it's important to consider how many we should keep and what level of accuracy our results should be reported to. So in this example, a very typical acid-base example that we'll learn more about later in the course, A student is mixing 500 mils of a 0.5 molar solution of hydrochloric acid. So molarity is a concentration unit that we'll discover later on. But he's mixing that with 300 mils of 0.8 molar NaOH, sodium hydroxide. What is the resulting pH? So it doesn't matter what's happening in this reaction or what's mixing with what. We're just looking at significant figures in this situation. So what we do when we approach these problems, whether we're going to be adding, subtracting, multiplying, or doing some sort of operation, is we have to consider how many significant figures are we given? What level of accuracy was the data measured to? So here we have one significant figure. We have our 5 followed by 2 placeholder zeros that we don't count. So there's our 1 significant figure. This one also has 1. We have a placeholder 0 out front. And then our 5, which is our significant figure. In this next one, the 300 mils, we actually have 4 significant figures. Those zeros are not placeholder zeros, they are significant places. So here we have 4, the 3, the 0, and the last 0 after the decimal place. Then lastly, we have here 0.8. This is again 1 significant figure. We have our placeholder 0 out front, and then our significant figure of 8. So when we do operations with data and significant figures, it doesn't matter how many you're given for each set of data. They don't have to be the same, as you can see in this example. However, your result has to be reflective of the amount of accuracy or the level of accuracy that your data was given in. So what we do is we pick the lowest number of significant figures and we go with that. So our results must be reported to 1 significant figure. We can't report it to 4. Because we don't have that level of accuracy for all of our measurements. Okay, so we have to report it to 1 significant figure. So we would do our math, and whatever that answer came out to be, say it was something like a pH of, I don't know, 10.82, we can only report this to 1 significant figure, and we'll talk in the next video about rounding these things. But to 1 significant figure, we'd have to report this to 10, it would round up to 11, so instructors would probably be okay if you said 11. But you can't include those decimal places because that brings us to 4 significant figures. So in this situation, we would only have our 1 significant figure that we're allowed to report because that's what the data is given to.